All right, good morning. Let's see if we can get through some test of hypothesis today. All right, so this is going to be 9.1, and what I'm going to do with us is come up with a plan of how we're going to do these problems, and I'll try to take you through the steps, but it's going to be a bit confusing until we go through an example, but I do want to outline our steps before we get into shelving an example here. All right. So the steps, and this is 5 steps every time you're going to do a test of hypothesis, okay, is you're going to set up 2 conflicting hypotheses. And what is this going to look like? Well, we have one-sided tests. Okay, we have a null hypothesis, and we abbreviate that H sub 0, okay? And that's going to look like mu is less than or equal to some value, okay? We have H1. Forgive me, the books that I learned out of called this HA, and that's our alternative hypothesis. And that is the conflicting part for this. So if mu is less than or equal to some value, then our alternative is that mu is greater than some value. Okay. We could also have another flavor, right? We could have HO, mu is greater than some value, okay? Or H1, mu is less than some value. Notice the equality always goes with the null hypothesis, okay? We have 2-sided tests, okay? That is HO, mu is equal to some value, okay? And mu is not equal to some value. Okay, that's how we set those up that way. The problem we usually talk to you about, we want something to be greater than, we want something to be equal to or not equal to, different than, or something is less than. So they're pretty clear about spelling out for you which one of these you're supposed to use. If you're ever in doubt, the 2-sided test is a more robust test than the one-sided test. So if you're stuck, I would say run a 2-sided test. That way you'll cover yourself. It's a safer, it's more conservative way of doing this. What that might look like more specifically, you might have a drug that might change a person's blood pH. So you might say HO. The blood level remains unchanged. The blood pH remains unchanged. 7.4 is norm blood pH. Okay. The nursing students were going to tell me that that's not entirely true. It's a little bit above and a little bit below this. That's okay. That's what the standard deviation does. That's why we do these tests, because it's not going to be spot on. It's going to be a little bit different. But what we're testing is how much different can it be before we can tell there's a difference. Okay. Our alternative hypothesis is not equal to 7.40. Okay. And remember with pH. Okay. Remember with pH. Here's 7. This is absolutely neutral. If you just type in water, that'll be 7. Blood pH is a little bit above. 8, this is more basic. Okay, so the higher level you go, it's more basic. The lower level you go, the more acidic it is. So, well, it's not too bad. If it goes from a 7.4 to an 8, yeah, if it goes up to an 8, you're probably dead. So a very small change here is going to be a drastic conclusion for the patient, okay? So that's the kind of test that you're looking for. Mu is either equal to 7.4, mu is not equal to 7.4, and then we're going to go through and run the rest of our steps here, okay? For a one-sided test, okay, if you're a quality control person, okay, you care if you're giving away too little beverage in your bottles, okay, because then you can get sued. If you're giving away too little product, you can get sued. So your care is whether or not you're shorting your customers. If you happen to be giving a little bit of extra, especially if it's soda because it's cheap. I mean, you don't want to do too much, but I would the cost of putting a portion, a fraction of an ounce in a bottle versus being sued is it's not worth the risk. So for quality control, you might say HO mu is at least say 12 ounces, okay, and H1 is mu is less than 12 ounces. Okay, you're trying to prove this. If you can't prove it, then we must be okay. All right. For this one, if you're concerned about, say, arsenic in your drinking water, the class runs in a southwest area of the United States. We have problems with arsenic in our soil, so it washes into a drinking water. So the EPA has to test. People have to test: is there too much arsenic in my drinking water? So we might say the null hypothesis is, what is it? 0.010 parts per million of arsenic. Okay, and then you might be concerned about it. Okay, you're trying to prove and say, well, it's bigger than 0.010 parts per million. Okay, these are good examples of a one-sided test because nobody is ever going to go off and complain and say, hey, I need more arsenic in my drinking water. I mean, that just doesn't happen. You're like, hey, there might be too much arsenic in my drinking water. That's what you care about. The EPA comes off, and HO always goes to the status quo. If the EPA says there's a safe level of arsenic in your drinking water, then we have to assume this, and we're looking to see whether or not this is true because this is what we're concerned about. If you're slapping, this beverage contains 12 ounces, then that's the status quo. And as the quality control person, you're caring whether or not you're shorting people, and you're worried about you're getting sued. This drug does not change the blood pH. You're concerned maybe it does. And if it does by too much, I'm out of frame. So this drug does not change the blood pH level, but you're concerned that it does. Okay, so that's the concern is here. Okay, the concern is always your H1, your status quo. That's your HO. Okay, so if the box of cereal says 16 ounces, then HO is your 16 ounces. Okay, so that'll be a little bit more clear as you get a little practice at it, but we'll go from there. Okay. Next thing we talk about is step 2. Okay, and these are not going to all be done in excruciating detail. Okay, we'll do examples especially step 3, we'll let an example do that. This is, you're going to declare your level of significance. Okay, this is alpha. In every problem in an introductory stats class, they tell you what alpha is. There are some books, though, that say you could leave the choice of alpha up to the reader. I'm telling you, don't ever do that. You choose alpha. Okay, let me talk to you about what error is and why we choose alpha the way we do. Okay, and I think the best way to do that is to have an analogy of a trial. Okay, most people have seen enough Law and Order or Perry Mason or whatever other thing you're looking for. Any courtroom drama, you're going to be able to follow along with this. Okay, so this top row, this is going to be what the truth is, and this might be known to one person, it might be known to a few people, in some cases it might not be known to anybody. Okay, and here's what the jury's conclusion is. This is your conclusion on a test of hypothesis, and unfortunately, we'll never know the truth. Like, we can talk about arsenic in your drinking water, and I could test it. There still might be an above 0.010 level of arsenic in drinking water. Maybe my test wasn't very good, and I said it was safe, but it wasn't. Okay, so the truth in America, we're supposed to have the presumption of innocence. So I'm going to go ahead and put innocent there. We can have an argument of whether or not that's still the way life works, but at least on paper, they claim that your presumption is innocent. Okay, and then we have guilty. And then the jury doesn't really find you innocent, does it? The jury finds you not guilty. We have no evidence to say he's guilty. That's what this is saying. Okay, and then guilty. Okay, and again, we can have a very long discussion about what innocent versus not guilty is, but pretty much innocent is you didn't do it. Not guilty is we either don't have enough evidence to say that you did it, or maybe you didn't do it. Okay, so if the truth of the matter is the defendant, right, is actually innocent, and the jury says, yeah, not guilty, okay, then there's no error here. Okay, if the defendant actually did it, and the jury says, yeah, guilty, then there's no error. I mean, it's probably a horrible thing that happened here, but at least there's no error. Okay. If the person is innocent and the jury says, take him away, then we've committed a type 1 error. Okay? You've sent an innocent person off to jail. That's what this is. The null hypothesis was true, but you said reject it. Okay, you said the null hypothesis is true, but we're finding otherwise. There's a safe level of arsenic in your drinking water, but we said, no, it isn't. The blood pH remains at a safe level, and we said, no, it doesn't. Okay, we measure this with alpha. Okay. This is the same alpha that we found for confidence intervals. Okay, for guilty, for the other one, see, statisticians are very creative people, so we come up with excellent names for this stuff. We've committed a type 2 error. And instead of alpha, we measure this with something called beta. We don't go into this in this class. Okay, this is a more advanced topic. Beta is the null hypothesis is false. Okay, so we're looking at the alternative hypothesis, but you failed to detect it. Okay, there is a hazardous level of arsenic in your drinking water, and you said, no, it's safe. Go ahead and drink it. Okay, see, my cat chimed in. She's very unhappy about that. The drug does change your pH level. But you said, no, it doesn't. Okay, so we care about this because in confidence intervals, remember, we couldn't have alpha. We couldn't have too big of a confidence interval because then it wasn't really useful. And it's kind of, this is under the hood part of it. If you really clamp down on your alpha, right? You say, I don't ever want to send an innocent person to jail. Okay, and hopefully that is rare, but we don't ever want to do this. Well, what's going to happen if we've committed this, or you don't want to commit this thing, then you're going to make the prosecution have a very high level of problem here. Okay, so if you clamp way down on alpha, right, and you say no, we have to have half a dozen eyewitnesses. We need spot on genetic testing for the crime there. We need taped evidence of them planning the crime and them carrying it out. Then the prosecution has a very high level to meet. So what's going to happen is you clamp really down on beta, or alpha rather, you clamp really down on alpha, then your beta goes up. Okay, and you don't want that either because you're letting a lot of guilty people walk free. So that's why they say a reasonable doubt. Okay, if you say, you know what, I never want to have a guilty person walk free. Well, if the guilty never walks free, then you're the kind of person that says, well, if he's in court, the police must have picked him up for something. He's guilty of something. Let's just send him away. So you clamp too far down on this, then this error goes up a lot, and that's not a good thing either. So we have to have a compromise. We have to have a balance of both of them. And depending on what the severity of making this is, that's what's going to drive what your acceptable risk is of making this type 1 error. Okay, I do this more to give you a heads up with the homework because they are going to ask you about type 1 and type 2 error. I tend to never quiz on type 1 and type 2 error because the names are so descriptive. But I want you to realize that type 1 and type 2 error, if somebody says to you, we've committed a type 1 error, I want you to be able to say something like, hey, what does that mean again? Or realize that the null hypothesis was true. We've committed this error. You probably won't remember that, but but I want you to know that they're not blowing smoke. Like, that is a thing, okay? There is type 3 error and type 4. These involve asking the wrong questions and getting the right conclusion for the wrong reasons. Okay? We don't talk about this in the class, but that's what you're going on about. Okay, so let's have a look on step 3. Okay, like I said, you always want to declare this at the top, and again, I'll show you an example of why you want to do that. Step 3 is we're going to calculate our test statistic. Okay, the calculator will usually do this for you as long as you pick the right test these days. And just like for confidence level, we have a situation where sigma is known. We have a time when sigma is unknown, and we have proportions. Those are the 3 we deal with in our class. There are other test of hypotheses that we don't really deal with in the class, but there are others. Okay, so to calculate test statistic, it's going to depend on what the situation is. Do I know this? Do I not know this? Is it a proportion? That's how we're going to take care of that. I'm going to let us look at calculated test statistic in the example. We're going to go from that. Step 4 is you're going to calculate from your test statistic. You're going to calculate your p-value. Okay. And p-values are a little bit complicated to explain to people, so if you don't quite get this at first, that's completely understandable. Most people don't. It's the probability of getting a result at least as extreme as the one that you got. Okay, that probably made no sense. But it's the probability of getting a result further along. So sadly, I grew up in the Northeast. We had Love Canal. And that was a terrible tragedy of a housing development being built on top of a toxic waste dump. And you might end up with, I don't know what the percentage of kids that come down with leukemia is, whatever it is, it's too tragic, it's too big. But in Love Canal, like the number of birth defects, the number of childhood cancers we had was insane. So what we're doing is we're testing and saying, okay, we might get 1 in 10,000, maybe 1 in 100,000 kids get leukemia. And in Love Canal, that was a lot higher. Okay, it's like you're the only one in your kindergarten class without leukemia, kind of a thing. So when we're saying at least as extreme for your p-value, like it could be worse, but the probability of getting worse is what your p-value is. Okay. So that's with that. And again, when we go through and we do an example, I will show you what's going on with the p-value. It'll make a little bit more sense with an actual number, with an actual example, but then we're going to go with that. Okay, that's step 4. Step 5, okay, this is our final step, is you're going to draw your conclusion. And your conclusion, you're going to start off, the book will do this for you a lot, and more advanced texts will do this, and they'll say, reject the null hypothesis, or do not reject HO. Remember, we talked a little bit about innocent versus not guilty. That's the kind of thing that you're doing here. You're saying, well, he ain't innocent, or he's not innocent. I mean, that's kind of weird double speak, and there's a lot of negatives in there. Your English teacher will probably be very upset with you. And quite honestly, I will be upset with you if you finish the problem and say, oh, we reject HO. Like, okay, that's great to anybody who's been studying this recently, but if you tell somebody reject HO, they aren't going to know what the hell you're talking about. So when you write this, you write a sentence explaining what this means in the context of the problem. So back to HO, HA, if we're looking at blood pHs, okay. If your conclusion is reject HO, that means this ain't true, okay? So reject HO, the blood pH changes in a way that's going to influence the patient. Okay, the blood pH changes to a level unhealthy for humans. Okay, you don't have to be as formal as the book makes you write this. Okay, they'll have little having little drop down menus for you to type this in. If you're typing this in by hand, if you give me the general gist of what's going on with what this means, I'm real happy with you, because that means you've internalized what this means, and you can say what's going on here. Okay, do not reject HO. Then technically we have no evidence to suggest that the medicine changes it to an unsafe level. That's the conservative and professional way of saying this. If you just tell me the blood pH remains at safe level, I'm pretty happy with you, because you've internalized what this means, and you can get a useful conclusion out of what's going on here. Okay, if you're telling me there's no evidence to suggest that the blood pH has changed, maybe for you that's a perfectly reasonable thing to say. Most people are going to look at you like, wait, what? And you're safe. It's going to be fine. Okay, so if you do not finish your test of hypothesis with an actual in English explainable to somebody who has not had statistics or not had statistics for 20 years, then that's okay. You have to finish with something like this. All right, and that's your 5-step process to doing this. So just to summarize here, we're going to set up hypotheses. We're going to declare your alpha. Okay, and again, this is a free step. It's given to you in the problem. Okay, and your books and the way I write these things, we try to be real clear as if is it greater than, is it less than, is it different than? Okay, so I'm not trying to trick you with the English here. It's hard enough. The alpha that's given to you, they'll say, it's usually part C. It's like draw your conclusion with alpha equals 0.01 or something. Okay? Just like confidence levels, your three most common p-values or significance levels are going to be these three. Okay, 90% confidence interval, 95, 99. Okay, if it's two-sided. 3, you're going to calculate your test statistic. Okay, this is going to be problem dependent. 4, you're going to calculate your p-value. Now, the good news is that in the 21st century, we have pretty advanced calculators, and the calculators will usually do both of these things in one step. So this is usually a calculator process here. Okay, so you can combine this and you can say, look, I used the calculator. This is the steps I typed in. Again, we'll go over this in just a moment. These are the steps I typed in. This is the output. This is the relevant output that I got, and we're okay there. And then step 5 is you're going to state your conclusion. And I'm going to say in a sentence, that makes sense. In context of the problem. Okay, so I'm going to stop us there, and I will do an example in the next video because this is already getting too long. And here you can, can't do that. You can make my cat a star here. She's very interested, and we'll talk about it next time. All right, thank you.